Yeah, right? Yes. A very warm welcome to one and each of you present here today. I am Raj, the technical head at IEEE SIS GST, and I'm thrilled to be your host for day 2 of Epsilon 2024. Yesterday was packed with learning and excitement, and we are glad to see so many of you return here today. The theme for this year's event is Synergy of Realities. And today we'll be focusing on the fascinating world of AR VR in digital twins. Joining us is the Joint Secretary Naeem Parker.
Thanks, Raj. Hello, everyone. Hello, and good morning, everyone. Myself, Naeem. So, yesterday set the stage, and today we are diving into how AR and VR are revolutionizing the industries like healthcare and architecture. So, we've got our hands on workshop titled Virtual Biz, where you will actively explore how these technologies are used in business setting. So, it's going to be super interactive and it will be packed with real world applications.
And to make things even more engaging, we'll be having after the workshop we'll be having an interactive Q&A session with our guest speaker, and you guys will have a chance to directly ask your burning questions to our expert, and this will be followed by a competitive quiz session. So, moving on, let me introduce you to our guest for today. We are honored to have Mr. Pierpaolo Vergati. He is a senior construction project manager with extensive experience in integrating digital twin technology in construction projects. He is also a NIME certified trainer and an alumnus of Sapienza University di Roma. His expertise lies in using data analytics and advanced technologies to revolutionize the construction industry. Today, he'll be walking us how AR and VR are enhancing the capabilities of digital twins in various industries. Let us give a warm welcome to Mr. Pierpaolo Vergati. Hello, sir. How are you?
Thank,
Hello, sir.
thank you. I'm very good. I'm very excited, most of all, to be here with you. Honored to have received this invite to share my knowledge, and I will be very happy to be able to show you something interesting and committing for all your students. For everyone is connected today. In Italy is quite early in the morning, but not so early. So probably we will be also some Italian friend or some Italian curious people in order to understand is if possible to create a digital twin and how, most of all. And this is probably the more interesting part because I like to create something very concrete for this application, not to have also only like a sort of theory, but I like also to make some very insightful and useful, most of all, insight for my presentation, and I hope that you will be appreciate it.
Sure, sure.
So
That-
I think that I can start now to
Uh,
share my screen.
yes, sir, you can start.
Yes,
Perfect.
they're
Thank you so
handing
much.
over the session to you, and all the best. And for the audience, make sure to pay attention to his presentation and explanations attentively, because the questions in the quiz will be from the presentation. So, handing over the session to you, sir. All the very best.
All the best, sir.
Thank you so much, and pleased to stay with you. So, today I will try to introduce you how to create your own digital twin and I'd like to also to give you some tips to how to create a very simple machine that will be able to explore it with virtual devices, with your own devices, any kind of your device that you have. And this presentation is focused on my industry, the construction industry, but you can use it this knowledge and everything I will show you for your own purpose, from automotive to manufacturing, healthcare, who knows, also finance probably. I know. Okay, a little bit about me. I am a graduate building engineer from La Sapienza of Rome. 2007. So I'm not so young, as you can see from the gray bird and gray hair. And I work in a CDP group since 2011. This is a financial company in Italy. I received a second master's degree in system engineering from the Polytechnic of Milan 3 years ago, and last year I received also a master's degree in digital twin artificial intelligence applied in the construction industry. From my final thesis project published in the Algae World USA magazine in May 2023. You can see the link here. And I realized a digital twin from the headquarters of my company, and it will be the prototype. Will be the prototype for the realizing a concrete digital twin, correctly streaming data in my company headquarters. I have a little son, Gabriele, and I hope he won't disturb us during this presentation, because probably he's now wake up. He's waking up now. So this is the agenda. I will try to introduce you a little of the what are digital twin, but probably you have also received this explanation from my previous speakers for the yesterday. But I will give very few pills. I try to introduce a data analytic approach from fundamentals and steps, and I will try to introduce my approach to data analytics, because as you can have understood from my background, I have an engineering background and not a computer science background. But I think that an integration of these two topics will be useful, most of all for a company like the construction industry that is quite receptive to integrate innovation in its processes. But I strongly believe that with the strong digitalization approach, also the construction industry will explode with these processes. I tried also to give you how to transform a simple model from the construction in something that can be explored in a augmented reality, virtual reality, and I'll also introduce you some useful tools in order to create your own data streaming, to manage data, to insert in your own digital twin, because without data, a digital twin is only a 3D model. It's not so useful. And after that, I will try how to extract information and to use it for your business intelligent decision in order to create a data-driven decision-making process. What is a digital twin? It was created, this concept from Michael Gritz, an engineer from NASA, in 2002. This is the image taken directly from the notes that Michael Gritz showed in the 2002. This data explains almost everything. You have the physical spaces, the physical world, and the virtual world. The physical world provides data to the virtual space. The virtual space provides simulation and information to the physical world in order to allow the human to make the correct decision. Obviously, from 2002, this image had been very sophisticated, but all the concepts are mainly the same. But why we could need the digital twin? You can see directly in this image. I won't read it because I like to explain it with the same metaphor used from Michael Gritz in his speeches. How many crash tests can you make with a car? Only one. How many crash tests can you make with the digital twin of that car? An infinite number. This is the very reason for the digital twin. The simulation is more cost-effective than physical realization. Augmented reality, motivation in the construction industry, but also in all your industry, you can find a lot of advantages in using augmented reality, increasing, for example, increasing your collaboration with your colleagues, quality checking for from the construction site, clash detection for many different expertises from the MIP, from the structural world, and so on. Unfortunately, as you can see from this image, in construction industry, the sector is not so digital ready. This is a very famous insight from the McKinsey Global Institute analysis that see the construction is at the least position in this chart. But in the construction industry, there are a lot of interesting in the BIM, the building information modeling. This is a kind of modeling in standard used in the construction industry, and all the topics that are very interested in extremely high impact, extremely likely in the construction industry. This is all the applications that I thought could be useful in the construction industry, from facility management for from the improving collaboration and communication for colleagues, stakeholders, anyone, and construction operation management in order to inspect, for example, the realization of a renovation construction site. And I'll try also to explain a little better quality assurance during the construction facility in order to inspect correctly how your system are, if they are working properly in your own buildings. Safety management, for example, through usage of the computer vision in order to inspect if any worker is wearing correctly all the devices that he had to wear. Helmet, gloves, boots, anyone. Project controls, very useful for large construction site where there are a lot of elements that you have to inspect. Collaboration and knowledge improvement. For example, you can extract the data sheet of a component that you are inspecting with your own devices and read currently all the characteristics of the component directly. How you can create your own platform in augmented reality, virtual reality, and mixed reality. There are mainly two types of solution. A customer modular solution that can be deployed with a blend of tools that tailored directly for your own purposes, and in some of these tools you can also create your own digital twin with your own platform with some also open source tool. There are also commercial cloud platform offered from the most famous big company that use the commercial cloud. I won't explore this because it can be a little bit expensive, but there are also some solution also from construction software companies. What we'll need to create a platform? We obviously we have to deal with a 3D model from database management systems. We have to create a platform ready to receive the information and data sources from a lot of sources, and also a data analytic platform with also AI features in order to explore simulation and cognitive capabilities, because without this, the digital twin realized can be not so effective for the purposes of your purposes. In this presentation, we will explore mainly these highlighted items: external sources, IoT, data flow management to create an effective workflow for your data. Explore also how to create interface that can be effective for your information to get information for your digital twin, and also to give you samples how to create shim, because the last part is probably the most interesting, effective, wow effect part, but is probably the last part is with less work to have to be done. So I prefer to be more focused in the working part. Data analytics. What is data analytics? Data analytics is a term that refers to a series of techniques aimed to extract data from values, because data taken like they are is not useful. You have to clean, manage, and it's not walking in the park. Can be a nightmare, because before giving you the possibility to show your information, you have to individuate your data sources, extract your data, clean your data, transform your data, and all the at the end you will be able to visualize your data. It is a fair tale, or they really work? I try to answer this with a movie. Probably you will find it on Netflix. This is the true story of the Oakland Athletics. There is also another one. This is The Big Short, with the same actor in this case. This Brad Pitt. Is focused on the 2008 crash, bankruptcy of Lehman Brothers. But in this case, it's more funny to see the Moneyball movie. Which kind of categories of data analytics we have? We have a descriptive analytics, predictive analytics, and prescriptive analytics from my point of view. Descriptive analytics describe you and answer you to what happened in the past in order to explore and explain how your data are telling, what your data are telling you. The predictive analytics are focused in the creation of probabilistic models aimed to predict trends and to suggest you what could happen. And the prescriptive analytics is a more advanced methods with more strong use of machine learning modeling and algorithm, and will directly tell you what to do. This is all the steps of data analytics, from the data access to the export and visualization. I want to make a very silly question. What is the best programming language for data science? All the answers are correct, but I think that data science is different from the knowledge of a single programming language. Data science is not just about knowing a programming language, but is an application of logic and methodology. Only with this, you will be able to deploy your own workflow for data science, and after that, you can extract your own information. If you apply this kind of reasoning, you can tell me that you won't need a strictly knowledge of programming language. You can apply also a visual programming approach, and this is probably could be very interesting, because you can have this quick tool comparison between a lot of tools for data transformation, advanced analytics, visualization, and also a user friendliness. From my point of view, the use of a visual programming approach can be more effective to deploy quickly your own your own data science workflow to manage your data. This is the KNIME Analytics platform. This is a open source tool. You can find it directly on the KNIME website. And after that, you can download it. There are more than 4,000, probably more, very more than 4,000 of nodes. And using metaphorically the same phrase sentences from the Apple Store, there will soon be a node for that in KNIME for your purposes. Whatever your data challenge, just plug it in and let the workflow magic happen. Like you will find your node to do your own duty, or a group of nodes in this case. This is the quick introduction of the user interface of KNIME. You can see when you install and open KNIME, you will have this user interface. You will have the workflow editor, the node monitor in order to understand what happened in the node, the application tab and description tab, where you can shift from the description of the node, searching from the node repository which node you want to use. And a very tricky introduction, there is also Kai, the KNIME AI assistant, that will help you to find and create your own workflow if you have doubt about which kind of node could be used for your purpose. You can see the node repository as you can only by a drag and drop node in the workflow and a little bit of configuration. This is the browse your workflow in your local space, but also a cloud space for your workflow. And that, with a drag and drop, you can connect the node from the left to the right. The connection is the black triangle with the black line. And you can connect the output of the node with the input for the following. And this is a quick introduction for the KNIME workflow on the left. You can have read nodes that are usually colored with the orange in orange. The transformation node that usually are yellow, and green from dark green to light green that usually are node used for the machine learning from learner and predictor, and the deployment in the red one. There is also the blue node that used to explore, to have a graphically representation of your data. Typically, the node is as an action bar where you can play, stop, and the execution of the node. Traffic lights in order to understand what's happening. The red light is not configured. Yellow light is configured but not executed, and the green traffic lights executed without any issues. This is also the fourth situation. Yellow with red X. It is the node has incurred an error during the execution. This is the PowerBI that where I integrate all the information to deploy digital twin. I will show this slide very quickly because probably you already know how to use Power BI, so probably it's not so interesting, but the only interesting part is I will show you the interesting part is the integration of the BIM model, the 3D model of your own physical asset inside that tool that provide you information for your purposes. So I will start to show you the KNIME Analytics platform. First of all, I'd like to ask if anyone can see my screen before continuing in this. Perfect. I received some okay from the okay. I will show the KNIME. This is KNIME, as I showed you during the presentation. This is the workbench where you have to do your work. You can directly take your own node and with a drag and drop in your own spaces. In this project, I have used local files, but you can change this connection with a local file to a database management system like SQL. I'll try to show you the connector. You can have any kind of SQL connector, MySQL, SQLite, Postgres, and Microsoft SQL Server. So you can connect your data. In this workshop, I will show you how to connect the data table taken from the IoT energy consumption of a physical asset. But instead of looking and reading CSV reader, you can use SQL connector and take the data from SQL. How this node work and all the node from KNIME. You take your drag and drop, configure your own node. In this case, it's a CSV reader, so it's more simple to browse where your local files is located, and after that execute. In this case, you can't read the word execute because it's already executed, but you can read the result, and the result is the data table. This is a quickly preview, but if you want to read it completely, you have this data
Yes,
table.
I'm audible.
You have a lot of columns. Yeah, tell me.
Sir, your presentation area is not visible, sir.
In this case, okay.
Could you check that, please?
I'll try. Okay. Now you see my... Okay, I think that now you can see my screen, sorry.
Yes, sir. Yes.
Perfect. Okay, as a quick step rewind, this is the KNIME user interface. This is the KNIME workbench, where you can drag and drop your own node from the node repository. In this case, as I told you without showing, sorry, but in this case I have used a local file to create this workshop, but you can use also a connection with the database management system from SQL, because I did SQL for the searching node. You can see you can use any kind of SQL, but any kind of data sources you can find it. After that, I use the same only to show you how to create it. The node is not configured from the red light. After that, in this case, is a CSV reader. You have to browse where is your file, and connect it with, and after that execute. In this case, you won't find the word execution because that is already executed, as shown from the green light in this icon, and you will find the data table after the execution is correctly imported inside KNIME. This is the name of the column, how many rows, about 20,000. This is a lot of data. This is also the data type from KNIME, and the connection to the following node to create all the information taken from this energy group of IoT sources for energy consumption. This is a string to date. This node changed the data type from string because the first column, as you can see, was a string, even if the information inside seems to be related to date and time type. So I used it to change the data type. In this case, is correctly local date and time. I used a lot of node in order to deploy this workflow. I try to show some very tricky and wow effect node in order to show you what you can do with this. This is a line plot because I wanted to understand if in my data is a time series. Probably you already know there is a sort of seasonality in my data, and you can see this is the hourly consumption, day by day and week by week, and this is 2 orders of seasonality. We have a seasonality, daily seasonality, and also a weekly seasonality. There is a Saturday and a Sunday probably. I also try to understand if there is also a yearly seasonality. So I also explored the aggregated data in order to understand if there is also a yearly seasonality, and I can see there is a seasonality every year. You can see the consumption month by month. This is the consumption at the July month. This is the July 2021 because probably this asset wasn't completely completed in 2021, but in 2022 the consumption increased. So probably in 2022 this asset has been completed. But as I told you, you can also try to make a machine learning algorithm with this tool. Why I decided to deploy also a machine learning algorithm? Because we have the possibility, most of all, because also it's useful to understand how a prediction of energy consumption can help probably a building manager if there is the possibility to improve the cost effective of your building. And I will show you, but at the last part of this presentation, some useful insight in order to understand if there is also an interesting characteristic and interesting insight by understanding what can happen in the future in your own building. We have the data loading loaded from the same data sources, the energy IoT data. The data manipulation is the same steps used in the previous workflow. In this case, I have also created a network architecture of the to realize the prediction. In this case, I used a neural network, is also a low short-term memory neural network to be more correct, with the 3 layers, an input layer, a LSTM layer, and then lastly an output layer in Keras. I have used the learner by using a partition splitting from 70-30, very common. And then I have also obtained the energy prediction. It's not completely good, but with real data probably is the most that can be done. But in some moment, there is also quite good accuracy. So it approximately in a very sufficient way the prediction of the energy consumption in this building. Well, this is the data analytic part of this digital twin. But where will I be able to see the integration? I used, as I told you, PowerBI. This is a little spoiler, I know, but I wanted to show you the most interesting part. Well, this is the PowerBI interface that is fitted for this purpose, but the most tricky part is this chart. This chart is provided from an Italian company, is Bilogic. This component is called the VCAD, and is a tool that integrates the model. The 3D model is uploaded to the Bilogic platform and integrated with the data taken from, in this case, from KNIME, already cleaned and aggregated for my purposes. You can see the consumption for any kind of items, from chillers to water pump to air handling unit. If I select one of them, the element is automatically highlighted and zoomed to find it in the model. From chiller, the second chiller, to the probably too zoomed, but if I make the X-ray mode, okay, you can see it very, very directly. Well, this is the digital twin part. In this case, I can see where is the object. I can see where is the object, where is the element, but I also try to make a little quick step forward, because also I wanted to know the single element. And as you can see, a tooltip created directly in this element. I can read the energy consumption, the total energy, the mean daily kilowatt per hour, the max daily kilowatt per hour, and probably in the date part is taken probably this was this one, sorry, the average daily consumption, where I'll be able to understand how is performing my cooling tower or my condensing water pump. Oh, in this case, there is a peak of energy consumption. So in this case, I have a feedback and information. As I told you, the digital twin provide me information in order to be more focused in my duties. My digital twin make all the dirty work. I prefer to use this kind of metaphor. The digital twin make the dirty work, so I'm free to focus in the where my action could be more effective. In this case, I notice a peak of energy consumption. The peak of energy consumption can be, in that day there will be actually a very hard energy consumption for this device, or maybe could be an error in the IoT sensor, so I can send the global server to check if the IoT is correctly working, or maybe something else, who knows. It's very interesting, but as you can see, the energy consumption peak is quite common in that moment for also other devices. So probably in that day is quite absurd that all the energy IoT device has the same peak of energy consumption in that moment. So probably there could be a sort of very strong energy consumption because something happened. But this is a feedback that only through this kind of analysis you will be able to take your own informed decision. As I told you during the presentation of the slide, you will be able to create a data-driven decision-making process. In this case, I can be focused in discovering why there will be that energy consumption peak. I can also try to make a filter from air conditioning to water pumps items to air conditioning if I want to focus only to one element or other one. As you can see, the energy consumption is also can be appreciated in this chart. So let's see also other dashboard. This is the total energy consumption. Is also only a dashboard to inform the energy consumption day by day, and you can also modify the date of your own analysis by using these sliding elements to be more focused on your purposes. And it also the trends in order to understand how your building is performing year by year. In this case, I have energy consumption data only for 3 years ago or 2 years ago, because this is a local file data sources, so I don't have the energy consumption from the previous year. But in this case, you can see that 3 years ago the energy consumption were lower because the building wasn't completed, but with the completion of the building, the energy consumption has increased about 30%. I have also deployed the energy prediction, even if it is for the last year, but obviously because the energy prediction is extended for only 30 days after the last energy consumption data. In this case, were last year, so that's why the energy consumption was stopped only at the end of July 2023. This is the energy consumption predicted from the machine learning algorithm, the LSTM neural network. I want also to show you a very effective digital twin that is currently working from the headquarters of my company. This is the prototype, and this is also the master project from my thesis in construction digital twin and artificial intelligence. And this is another interesting feature that can be deployed with this blend of tools. In this case, I focused on the space management of my headquarters in order to understand how my booking data from all the data of my colleagues, how my headquarters is working. Most of all the desks are booked from all my colleagues. I want to focus in this case for the plan 5. This is the typical floor from the buildings, where there is an open space with some meeting rooms and also some single rooms office. You can see the single desk, and this is the occupancy day by day, tenant by tenant, because the headquarters had a group of companies inside the buildings. As you can see, I have also detail from the desks in order to have the percentage of booking by floor, from P7 to P1, P01. I have also some interesting elements from the meeting rooms. Oh, this is a very, very interesting aspect that when I showed this to my boss, was quite surprised, but I explained it to him, and after that he wasn't surprised, but only get a little bit angry, because you can see this is the mean duration of a meeting in my company. So almost 4 hours, a very long meetings. I explained that probably some colleagues don't want to stay in open space, probably use the meeting room as his own office. It's not correct to use a meeting room as your office because you want to stay in open space. And I explained it to my boss, and probably now these colleagues now are using more properly their desks, and most of all they book their desk in the open space. As you can read, they've also tried to explore the energy management in of the buildings, and I've also deployed something for the understanding the prediction with an accuracy of about 80% of the occupancy inside the buildings. Quite low, because unfortunately these data derives from the COVID emergency situation, so there weren't so many colleagues every day by day inside my buildings. Let's see probably the last part. In this case, we have Unity. The last part, I use the Unity because it's open source, and I wanted to show you something that could be useful for all the students everyone who try to approach to this job, in how to deploy also a scene that can be explored with your own devices. I have used Unity in combination with Revit, in combination with a DIN in Revit is D-Roots. With D-Roots, you will be able to convert your file from Revit, and as I told you, also from ArchiCAD, in GLST file. From the GLST, you can import it inside Unity, and inside Unity, you will have your own scene that can be explored by your own devices. Unfortunately, I haven't used the same scene from the digital twin that I have showed you, because the conversion is quite expensive for the hardware, and I would have taken too many hours to convert it. So I prefer to show you a different element that is a quite simple building that is provided with the installation of Revit from the Autodesk company, and you can see is completely and correctly imported from in Unity. So now I try to explore the buildings only by using the keyboard and the mouse, but if you use, for example, Microsoft HoloLens or MetaQuest 2, MetaQuest 3, if you have your more recent hardware, you can explore the buildings in the same way. And most of all, you can also see how to insert the same tags and same elements in order to explore the information from the IoT devices. Okay, I think that I have now completed the presentation, so I'll be free to answer to all the questions from all of you. So I'm available for any kind of question. Raji or someone in the backstage that can share with me some questions from the students?
Yes, sir, sure.
So now we'll start with the Q&A session. So before that, that was a very nice session. Thank you for insights and enlightening the viewers from the point of view of how digital twin works. Thank you, sir.
Oh, thank you so much. I noticed that probably during the presentation, probably interrupted the screen sharing, but I noticed it, and I try to stop during the presentation. But obviously, all the students that probably could have missed some of this information will have the slides in order to follow what I have said during it. So sorry. I can see a question. How can you
Yes.
incorporate the predict model like energy consumption forecast into RR VR visualization in Unity, and how can that enhance decision making? Oh, very interesting question from this student. I'll try to make an explanation from the last part. Decision making, because is how can help the decision making part. So if you have a decision making process like the energy consumption, you will be able to correctly. It's more common in Italy, but I don't know if it's common also in India or somewhere else. If you are able to predict correctly your own energy consumption, you will be able, for example, to calibrate your financial prediction for the energy consumption bills. And if you want to improve your and be more cost effective for your own energy consumption, you will be able to take the right decision to improve your energy consumption. For example, as I told you, I showed you, for example, the space management digital twin in order to understand how to improve the situation of having too much long meetings. I discovered that probably some colleagues, and to make a funny jokes, without having any kind of hardware device, I will tell you also name and surname of my colleagues that use the meeting rooms as their own office, obviously, and you will be able to take this decision to prohibit to use the meeting room like offices. Let's try to respond to the first part of the element. You have a data table, because the energy prediction is a data table. A data table can be represented as a chart, as we showed in the Power BI. This data chart with the API from Power BI can be imported directly in Unity. It's not so simple to explain it, but I think that all of you can use, for example, any kind of large language models, and there is a quick, tricky C# script that can use to connect the web API from Power BI to Unity and import it, and then you will be able to see directly the tooltip window that, as I shown you in Power BI, directly in Unity. I think that is the more correct and direct answer to this question. How can a digital twin model be continuously updated using real-time data? This is a very interesting question. Okay, you have your own data sources, for example, the IoT devices. You stream your own data sources to, for example, for the IoT is commonly a time series data, can be directly streamed in the SQL, for example. Well, SQL can be scheduled the execution of your own workflow inside KNIME. You can schedule it probably also about every hour, also less than an hour. After that, you can schedule also the execution of the Power BI updates. After that, you will have your own digital twin updated probably also less than an hour ago. I think that for a buildings is enough for a building to have updated to the previous hour. I think that you can be able to update the KNIME workflow and then the Power BI execution also half than an hour. I have to alert you because with KNIME, the scheduled feature is not open source, is not free. If you want to have it, you have to pay, but the fee is very low because take only few cents of euros for every minute of execution. So it's quite affordable for everyone. Okay, any kind of. How can Unity's 3D model be optimized for real-time interaction when with a live data from digital twins? Oh, it's quite interesting. For the real-time optimized, there is the possibility to use a script to update the data from the Power BI, and so you will be able to have the energy data updated, as I told you, with KNIME and Power BI to the previous hours, probably also less than an hour. How does KNIME machine learning capabilities enhance the accuracy of digital twin model, particularly for complex energy consumption prediction? Well, this is the most difficult question that is very interesting. KNIME use and exploit all the knowledge from the statistics. So like Python, when you have you have Python, you have the same problems. When you have real data from the real world, how can enhance your accuracy? By testing. The more correct, by testing your own model. Try to improve the hyperparameters of your machine learning models. If you are not able to improve so effectively your own machine learning models, probably you have to change your model to another algorithm that probably perform better for your own data. The selection of the proper algorithm is related to your own purpose and your data, obviously. Oh, sorry, I lost the previous. What are the best practice for exporting large-scale energy consumption prediction from digital twin models to CSV for further analysis in tool like KNIME? Okay, in KNIME you can have not only local file or connecting with the SQL or database management system, like I showed you during the presentation, because you can also have access also to big data platform like Spark or Hive. So you can connect also to very large data. KNIME is quite good, and if you have a local installation, and talking about free software installation, you will have your own hardware capabilities. If you have a payment installation, you will have the capabilities of the cloud machines in hardware of KNIME. Is more powerful, obviously. It can be more effective with big data. But if you have very big data, so you are talking about millions of rows, probably you will have to shift to the use of big data platform. And after that, import and create your own workflow related to the big data. I hope to correctly. What are the main data sources required to build a digital twin model for energy prediction? How can KNIME help in processing this data? Okay, the main data sources required to build in digital twin is depending on your purposes. For the energy prediction, you can have Excel files or CSV files. Is more probably is 90% of the situation. You will have these two types of files, and then KNIME will help you to make the data wrangling and cleaning processes, because you will be able to deploy very quickly, because I haven't told you, my background is an engineering background, not a computer science background. That's why probably I don't have a so strong programming language knowledge, but also without having a so strong background in programming languages, with KNIME, I have been able to deploy all this transformation, and in my first attempt, the prototype for my headquarters that now is coming to birth to a very real digital twin, I have used probably some not so effective nodes instead. Now that I'm a little bit skilled, because I have a mindset is my mindset is I have to learn, and I'm ready and to learn everything. So probably help the KNIME helps in the pre-processing, because you will be able to deploy very quickly your own workflow. Are there any real-world applications where KNIME Unity and digital twin models have been used together to solve complex problems? Oh, we have to define the term complex. In construction industry, the use of digitalization, complex is everything, everywhere. Probably in other sector, complex are more related to very complex problems. Real-world application where KNIME Unity I have used in my own application of realizing a prototype of my headquarters, and in my headquarters I have presented my master thesis project to my boss, and my boss liked so much this concept that he wanted me to start a process to individuate a provider to realize concretely what I have taught to improve for my headquarters. So there are any real world application? I can answer yes. My headquarter company now will have soon a digital twin, and they will be used in this way. How can incorporate predictive models into AR, VR visualization in Unity? Probably in the same way that I have showed with PowerBI. The predictive models will generate a data table. A data table can be represented in a chart comparison with probably also the scoring accuracy, like all the metrics for the valuation of the accuracy of a machine learning models. So you can, for example, represent the energy consumption of your own device, and then you can show for to make an explainable artificial intelligence approach that's quite a buzzword now recently, and explain the percentage of accuracy of your own prediction. And you represent by a data table. It's quite simple, quite immediately understandable for your purposes. How does missing data affect the accuracy of prediction in digital twin model? Missing data affect any kind of accuracy in any kind of machine learning algorithm. I would like to answer, but I want to make a quick step forward. Week 9 we'll have a couple of notes that will allow you to manage missing data. You can apply all the statistic approach that help you to solve these problems. Some you can choose to delete completely the data, the row where there are missing data. You can change the values with the fixed values, with the meaning value, with the interpolated from the previous and the following data, or using the mean value in order to have a better accuracy for your prediction. The following question. How do you ensure data consistency and avoid error when exploiting complex 3D model data from Unity to a format like CSV for further analysis? Okay, let's probably data consistencies now to be sure that any kind of data can be the same from any kind of transformation. You can use, for example, a blockchain in order to make a checking for all the data used from all the steps. For complex 3D model data, Unity in this kind is the last part of this process. So probably from Unity, you want to have the needs to make any other kind of output after Unity. After Unity, you will have also only to explore your own machine. So in this kind, probably your format won't be a CSV after Unity, but you will have the CSV at the beginning of the process. But as I said, you can make sure of the data consistency by verifying the data sources by blockchain processes, and after that, the consistencies of your data applying statistical approach statistics to the use of KNIME.
So I suppose we are completed with the questions.
Oh, great.
Okay, so that was surely an engaging Q&A session. I'm sure everyone gained a lot of clarity about the topics that were discussed today. A huge thank you, sir, Mr. Vergati, for taking the time to answer all those questions in such detail. Thank you, sir.
Thank you to, and most of all, thank you for all the students that wanted to connect with me. And I will be available. Very happy if probably tomorrow you will have any other kind of question. Feel free to reach me through LinkedIn or also by using the QR of my contacts. You can write me, and I'll do my best to explain and solve any kind of doubt you could have in the future.
Surely, sir.
Thank you so much for you, Reggie, for Naim, Drushdi, and anyone helped me in this very engaging meeting with all of you. Oh, thank you also to Araya for this very very pleasant comment, amazing session. Thank you. I'm very happy that you liked it. Very happy.
Sir, thank you for your words and appraisal. Actually, it was very fun to have you. And from the IEEE SISGC family, we'd like to give you a token of appreciation, a token of gratitude.
Thank you. Thank you so much. I'm very honored to have received all these messages from you and this token. I'm very happy. Thank you so much. And have a very great session for the following speakers that could be very interesting too.
Thank you, sir. It was an honor to have you with us today.
Me too. Thank you.
So, so sorry, guys. We had a technical issue. So now, before we move on, it's time for some fun. It is a quiz time. So the link to the quiz is posted in the chat box below. So you can take the quiz there. So now, speaking of upcoming events, don't forget we have the WI track presenting an incredible session at 1:30 p.m. on Spiking Neural Network. So stay tuned, guys.
Guys, we have had an amazing time with you all today. Thank you for being such a fantastic audience and for participating so enthusiastically. It's been a day full of learning, and we hope to see you back for the next session. Until then, this is Raj signing off, and see you soon.
And this is Naeem signing off as well. Thank you again, everyone, and we look forward to seeing you at 1:30 p.m. for the next session. Have a great break.